everybody again. And yes, my voice may sound weird sometimes, so just deal with that, okay? Chapter 12, Averages and Measures of Spread. Keywords: average, mode, mean, spread, median, range, discrete, continuous, grouped data, estimated mean, middle class, percentiles, upper quartile, lower quartile, interquartile range. Why are there so many of the word quartile? Box and whisker plot. In this chapter, you will learn how to calculate the mean, median, and mode of sets of data. Calculate and interpret the range as a measure of spread. Interpret the meaning of each result and compare data using these measures. Construct and use frequency distribution tables for grouped data. Identify the class that contains the median of grouped data. Calculate and work with quartiles. Divide data into quartiles and calculate the interquartile range. Identify the middle class from a group frequency distribution. Construct and interpret box and whisker plots. So, the newspaper headline is just one example of a situation in which statistics have been badly misunderstood. It is important to make sure you fully understand the statistics before you use it to make any kind of statement. Children required to achieve above the average. What? And then a bunch of lines. Oh. Okay. When you are asked to interpret data and draw conclusions, you need to think carefully and to look at more than one element of the data. For example, if a student has a mean mark of 70% overall, you could conclude that the student is doing well. However, if the student is getting 90% for 3 subjects and 40% for the other 2, then that conclusion is not sound. Similarly, if the number of bullying incidents in a school goes down after a talk about bullying, it could mean the talk was effective, but it could also mean that the reporting of incidents went down, perhaps because the bullies wasn't worth bullying if they were reported. It is important to remember the following. Correlation is not the same as causation. For example, if a company's social media account suddenly gets lots of followers at the same time their sales in a mall increase, they may mistakenly think that the one effect caused the other. Sometimes if we use the data that confirms our own biases, this is called confirmation bias. For example, if you were asked whether a marketing campaign to get more followers was successful and that the data showed that more people followed you on Instagram, but there was no increase in your Facebook following, you could use the one data set to argue that the campaign was successful, even if you believed it was. Sometimes we need to summarize data to make sense of it. You do not always need to draw a diagram. Instead, you can calculate numerical summaries of average and spread. Numerical summaries can be very useful for comparing different sets of data, but as with all statistics, you must be careful when interpreting the results. Recap. You should already be familiar with the following data handling work. Averages from Year 9 Mathematics. Mode is the value that appears most often. Median, the middle value when data is arranged in ascending order. Mean, the sum of values over the number of values. So, for the data set, 3, 4, 5, 6, 10, 11, 12, 12, 12, and 18, the mode is 12, and the median is 10. Because 12 appears most often, but 10 is in the middle. The mean is 9, however, which is not a number here, but it's still the mean, because it's the sum of all the 11 numbers divided by 11. Stem and leaf diagram, chapter 4. Here's the stem. This is order from stem. This is order leaves. And this is the back-to-back data set. So class 8, the key is 3 here, 7 here. If a 3 is here and a 7 here, it means it's 73, not 37. But if a 7 is here and a 9 is here, it means 79, not 97. I know if you just started watching this video, it may sound confusing. So if you do, go back to chapter 4. But please, after that, watch this video. I need views. 12.1. Different types of average. An average is a single value used to represent a set of data. There are 3 types of average using statistics, and the following shows how each can be calculated. The shoe sizes of 19 students in a class are shown below. So, how would you describe the shoe sizes in this class? If you count how many size 4s, how many size 5, and so on, you will find that the most common and the most frequent shoe size in the class is 6, with 1, 2, 3, 4, 5, 6 of them. This average is called the mode. What most people think of as the average is the value you get when you add up all the shoe sizes and divide your answer by the number of students, which is 6.25, rounded to 2 decimal places. 6.05. This average is called the mean. The mean value tells you that the shoe sizes appear to be spread in some way around the value 6.05. It also gives you a good impression of the general size of the data. Notice that the value of the mean, in this case, is not a possible shoe size. The mean is sometimes referred to as the measure of central tendency of the data. Another measure of central tendency is the middle value, when the shoe sizes are arranged in ascending order. If you think of the first and last values as one pair, the second and second to last as another pair, and so on, you can cross these numbers off, and you will be left with a single value in the middle. This middle value, in this case 6, is known as the median. Crossing out the numbers from each end can be cumbersome if you have a lot of data. You may have noticed that, counting from the left, the median is the 10th value. Adding 1 to the number of students and dividing the result by 2. 19 plus 1 over 2 also gives 10 as the median position. What there had been 20 students in the class? For example, add an extra student with a shoe size of 11. Crossing off pairs gives this result. You are left with a middle pair rather than a single value. If this happens, you simply find the mean of the middle pair, 6 plus 6 over 2, which is 6. Alright, guess if the two numbers of the middle pair are the same, then that's the answer, 6. Because 6 plus 6 is basically 6 times 2. But then you divide by 2. Okay. Notice that the position of the first value in the middle pair is 20 over 2, which is 10. Adding an extra size 11 has not changed the median or mode in this example. But what will have happened to the mean? So, in summary, The mode is the value that appears in your list more than any other. There can be more than one mode, but if there are no values that occur more often than any other, then there's no mode. Because there are no modes in the set of data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No modes. Okay. The mean is the total of all data over the number of values. The mean may not be one of the actual data values. The median will arrange the data into ascending numerical order. If the number of data is n and n is odd, find n plus 1 over 2, and this will give you the position of the median. If n is even, then calculate n over 2, and this will give you the position of the first, the middle pair. Find the mean of this pair. So, dealing with extreme values. Sometimes you may find that your collection of data contains values that are extreme in some way. For example, if you were to measure the speeds of cars as they pass a certain point, you may find that some cars are moving unusually slowly or unusually quickly. It is also possible that you may have made a mistake and measured the speed incorrectly, or just written the wrong numbers down. Suppose the following are speeds of cars passing a particular house over a 5-minute period measured in kilometers per hour and wait. No, that's supposed to be part 2! Oops. Thank you and goodbye.